So here we have some information about systolic blood pressure. The graph illustrates a person's normal systolic blood pressure measured in millimeters of mercury. So the mm is millimeters. The mm is millimeters, and the Hg means mercury. Okay. And it depends on their age. So they give us a formula. This is a quadratic formula that we're going to use. And that models a man's normal systolic blood pressure, P, at age A. So the P is the pressure, blood pressure, and A is how old they are. Okay, so there's the graph. We'll talk about that in a minute. It says for part A, find the age. So we're trying to find A to the nearest year if a man whose normal systolic blood pressure is 125. So that is the P. So I need that formula, and hopefully I'll remember it right. 0.006a squared minus 0.02a plus 120. Okay, so I think that's right. We know the P, so we're going to put in 125 for P. And then it is a quadratic equation. We're going to set it to 0 by subtracting the 125 off both sides. And so we get 0 equals 0.006a squared minus 0.02a minus 5. Now that is a quadratic equation. We can see what a, b, and c are. I'm not going to try to factor it. I'm not going to try to do anything with it. Just go straight to the quadratic formula. Okay, so the opposite of b, which is going to be 0.02, it's going to be the opposite of a negative number, plus or minus the square root of, and then I'm going to have b squared, negative 0.02 squared, minus 4 times a, which is 0.006, times c, which is minus 5, all over 2 times 0.006, because that's a. All right. I would take on my calculator and I would figure out the discriminant. In my calculator, I would put 0.02 to the second power. So this button, my little arrow, some calculators use that for the exponent. Your calculator might be a little different. And then it's going to be plus. Now why do I have plus? Because it's a negative times a negative. So, and I can put 4 times 0.006 times 5, okay? I probably would use the multiplication symbol here, and usually they use a star to indicate multiplication. Okay, I don't need all the parentheses. So let me put that in my calculator. 0.02 to the second power plus 4 times 0.006 times 5, and I get 0.1204. So you'll have to look at your calculator and work on that to be able to get that number. So that's what we want to make sure we have that. That's going to go back in here. So now I have 0.02 plus or minus the square root of 0.1204 all over 2. Oh, let me do 2 times 0.06. What's that? 2 times 0.006. 0.012. Okay, I'm going to make 2 cases here. I'm going to have the 0.02 minus the square root of 0.1204, all divided by 0.012. And then I'm going to have the other case 0.02 plus the square root of 0.1204 all over 0.012. Okay, so I have to be careful writing those numbers. Now, I can put this all in my calculator. Scientific calculators will do this. So what I need to make sure I do, though, is put parentheses around that numerator so it all gets divided by 0.012, the denominator. So I'll do the same thing over here. The other thing is, my calculator, when I put the square root button, it opens a parenthesis here. So I have to close that parenthesis off after I put the number in. Your calculator might do the same thing. So everybody's calculator is probably going to be a little bit different, so you might have to play around with it a little bit. Okay, so I'm going to talk it out how I'm putting it in my calculator. I'm opening a parenthesis. I'm doing the one on the left. I'm opening a parenthesis, 0.02 minus the square root button. The parenthesis is already there. 0.1204. Close the parenthesis, close it again, and then divided by 0.012. And I'm getting like a negative 27.2489, something like that. Okay, now if you remember what this problem was about, it was about finding age. Well, I don't think the man is a negative age, so I'm going to say that's not going to work. Okay, now I'll do the other one. Open that, so I'm doing this one here, parenthesis, 0.02 plus square root, and that opens a parenthesis, 0.1204, close the parenthesis, divided by 0.012. And I'm getting 30.5822, blah, blah, blah. Okay, that's okay. We want to round to the nearest year, so it's going to be 31 years. So the man was 31 years old. About 31 years old. Okay? All right, play around with your calculator so you can get those calculations. Now, part B says, use the graph to describe the differences in normal systolic blood pressure of men and women as they age. Well, it looks like right here they're crossing. So the women had lower blood pressure, but then they started having higher blood pressure after about age 50. The men had higher blood pressure until about 50, and then theirs was started to be lower than the women's. So it looks like women have lower blood pressure, systolic blood pressure, until about age 50. Then higher than men, lower blood pressure than men until about age 50. One thing I want to point out on this graph, see this little squiggly thing here? So when we're counting along the x-axis, you can see it's 0 and then 10, 20, 30, 40. But on the y-axis, or the p-axis, they're saying, okay, this little squiggly says skip over some numbers because we want to count by tens, but we want to start at 100. So that's what that squiggly means. It says we're not going to just do it from 0. We're going to skip over, and then we're going to start at 110. Or I'm sorry, 100. And then we can have a better picture of what's going on. Okay, just wanted to point that out.